Welcome, chemistry students. This video covers topics in Lesson 1 of your General Chemistry 1. These topics include properties of matter, classification of matter, chemical formula of common substances, and simple techniques in separating components of mixtures. Objectives: 1. Distinguish between intrinsic and extrinsic properties of matter. 2. Classify matter. 3. Recognize the chemical formula of common chemical substances. 4. Compare consumer products on the basis of their components for use, safety, quality, and cost. And 5. Describe simple techniques in separating components of mixtures. Let's start with the definition of matter. Matter is anything that occupies space and has mass. So everything that you can see that occupies space and has mass is considered matter. Even those that you cannot see may be considered matter. For example, you will see on this illustration a block of ice that is melting with the formation also of some smoky substance. This is a good illustration of the three states of matter, meaning to say, matter may exist in three states such as solid, liquid, and gas. So you will see the particles in solids to be in fixed positions, whereas the particles in liquids are separated and the particles of gas that are widely separated. What is the difference among the three? Yes, it's temperature. So matter may exist in any of the three states depending on the temperature. So therefore, matter undergoes change, and chemistry is the study of matter and the changes it undergoes. Let's have the properties of matter. You will see in this illustration or in this diagram the breakdown of the properties of matter. So matter may exhibit physical properties and chemical properties. Physical properties are further divided into intrinsic properties and extrinsic properties. Intrinsic properties have something to do with the quality of matter. So these may include the following: odor, color, taste, hardness, density, boiling point, and many others. Extrinsic properties, on the other hand, have something to do with the quantity of matter, such as mass, volume, weight, temperature, and many others. So you will see that most of the intrinsic properties are distinct characteristics of matter. For example, what is the distinct odor of water? What is the distinct odor of oil? What is the distinct odor of urine? So you can tell by odor if that substance is urine, oil, water, or any other substance. So it's distinct. Whereas for extrinsic properties, for as long as there is a measure, there is a magnitude, you can tell if it is an extrinsic properties. But you will notice density here under intrinsic property, as well as boiling point, and in addition freezing point and melting points are intrinsic properties even if they are having magnitude. So for example, density is expressed as gram per milliliter or per cubic centimeter, or boiling point in a scale of Kelvin or degrees Celsius or degrees Fahrenheit. So they have magnitudes, but they are not considered as extrinsic. So let me give another example on that. For example, water. Water has its intrinsic physical properties such as it is colorless, it is odorless, it is tasteless, it is liquid at room temperature. So those are examples of its physical properties. What about extrinsic properties of water? You put it in a container and identify or determine its volume as, for example, you fill in a container of water with 100 ml. So that 100 ml is already an extrinsic property of that water. You measure its mass in gram, you get another extrinsic property of water, but you try to boil the water. Water will boil at 100 degrees Celsius. You get another container and put a different amount of water. That same amount, that water, that same substance water will boil at the same temperature. So regardless of the amount, boiling point of water remains to be at 100 degrees Celsius. If extrinsic physical properties may vary according to amount, for example, 1,000 milliliter of water is smaller than 2,000 millimeters of water. Why did the volume change? Because you added more substance. So 1 liter is different from 2 liters and different from 3 liters. And this extrinsic property varies according to the amount of substance. On the other hand, the boiling point, even if it is a liter or a ton, 1,000 liter, it still will boil at the same temperature. It will just take longer for greater amount to reach that temperature of 100, but the temperature scale of 100 degrees Celsius remains to be the boiling point for water regardless of the amount. So that's what makes intrinsic properties distinct. Regardless of the amount, they remain the same. Oil boils at a different temperature, but any amount of oil will boil at the same temperature. Same with alcohol and other substances. So boiling point, density, and some others may have magnitudes, but they are considered intrinsic because they do not change as the amount of matter changes. Let's go to chemical properties. Chemical properties identify the chemical composition of the substance. For example, as a piece of paper burns, it exhibits combustibility. So combustibility is a chemical property. Once the paper has been burned, its chemical composition has been altered. So when a substance or a sample of matter undergoes a change and its chemical composition is changed, it is said to be exhibiting the process causes the substance to change its chemical composition, and therefore the substance exhibits this property. For example, combustibility in the case of water. So other examples of chemical properties are flammability, reaction with acid, base, alcohol, and other substances. So chemical properties also are associated with the ability of a substance to change from one form to another. Let's now talk about the changes in matter. Since we've been talking about change in matter. Changes in matter are categorized as physical change and chemical change. These changes are related to physical properties. When we fold a piece of paper, what extrinsic physical properties of this piece of paper are changed? We have the area and volume. The volume of the piece of paper is bigger or greater than the volume after it has been folded. So that extrinsic property of paper is changed, and therefore the change it exhibited after folding it is only physical change. On the other hand, if we do the process of burning, what intrinsic physical properties are changed? What are some of the intrinsic properties? We have the color, we have the texture, and few others. Once you do the burning of that paper, these intrinsic properties such as color, texture are changed. So that indicates that the piece of paper is undergoing a chemical change as it is burned or when it is burned. So that's the difference between the physical and chemical change in relation to their intrinsic or extrinsic physical properties. But in addition to that, we can also distinguish between the physical and chemical changes in terms of the process being reversible or the change being reversible or irreversible. For example, when you do the process of folding in this piece of paper, is the process reversible? Can you unfold the piece of paper? Yes. And you can retain the original paper. It's still a piece of paper. You can retain the volume of the piece of paper. The process is reversible. Burning is irreversible. Once you burn the pieces of paper, you can no longer retain its original composition. So when physical change happens in a sample of matter, the chemical composition remains or can be retained. Chemical change results to alteration or change in the chemical composition of that matter, and the process is irreversible. So those are the big differences between the physical and chemical changes. So some examples of physical change are folding of paper, breaking of glass, boiling of water. In the case of boiling of water, the phase change involved is evaporation. So evaporation, as we all know, is the process of changing liquid to gas, and evaporation has a reverse process, which is also common to us, the condensation. So if it's the reverse of evaporation, then condensation must be the process of changing gas to liquid. So notice that the process of evaporation is reversible and therefore only physical when a substance undergoes evaporation. So the change in substance is only physical. Same with melting and freezing. These two are reverse processes. So when a sample of matter melts, it can be frozen. So depending on temperature, so the chemical composition of the substance remains and the process is reversible. So the change in matter is only physical. Some examples of chemical change are burning of fuel. So once you burn any material that is flammable or combustible, you can no longer retain the original composition, and the matter is transforming into another substance. Other examples: decaying of plants, reaction of skin in strong acids, bases, or other substances, and many others. So I hope that's clear. Let's now move on to classification of matter. Matter has two major groups. We have the pure substance and mixture. What are pure substances? These two, water and hydrogen peroxide, are two examples of pure substances. Pure substances are defined as forms of matter with unique, fixed, and definite composition. So these two substances, notice, have different composition. What do I mean? Both may have the same set of constituent elements, hydrogen and oxygen. But notice the ratio of hydrogen to oxygen in both substances. In water, it's 2:1. In hydrogen peroxide, it's 2:2. So this means that these two are two different pure substances, and in fact exhibit different sets of physical and chemical properties. Mixture. What are mixtures? Mixtures are combinations of pure substances. When we mix salt and water, salt dissolves in water and therefore forms a solution. And a solution is a kind of mixture. So these two different substances mixing together, combining, form a mixture. So mixture is a combination of at least two or more different pure substances. Pure substances can be subdivided into element or compound. Elements are the simplest forms of matter. These are composed of one kind of atoms and can be subdivided further into metal, non-metal, and metalloids. Metals are hard. They are also good conductors of heat and electricity. That's the reason why they are used in as materials in kitchenwares. They are also lustrous. When stricken with light, they produce this bright effect that makes them, so you call that luster. On the other hand, non-metals are soft. They are poor conductors of heat and electricity. They are brittle. They are non-lustrous. Examples are hydrogen, the gaseous element. The 7 metalloids may exhibit the metallic and non-metallic properties. You can find the small number of metalloids in the periodic table as it is distinct by as the group is distinct by separating the group of metals and the non-metals in the periodic table. Let's have compounds. Compounds are combinations of elements. Water, hydrogen peroxide, and salt are examples of compounds because these are composed of 2 elements. So compounds may be composed of 2 or more different kinds of elements. They can be subdivided into organic and inorganic. The simple distinction between the two is that organic contain carbon, inorganic are non-carbon with some exceptions. Organic compounds are called the molecules of life. They are the macromolecules that sustain the life on Earth. They are divided further into the following: carbohydrates, proteins, lipids, nucleic acids. There is a separate lesson for the organic compounds. Inorganic compounds are grouped into acids, bases, salts, and oxides. Again, another lesson is also allotted for the details of these inorganic compounds. Mixtures may be categorized as homogeneous or heterogeneous. Homogeneous are called homogeneous because homo means one. Hetero means 2 or more. So water and salt forms a homogeneous mixture, and what enables them to form a homogeneous mixture? Because of the ability of salt to dissolve in water. The formation of one phase means the formation of a homogeneous kind of mixture. Heterogeneous, by the way, homogeneous mixtures are also called solution, while the 2 other subclasses, suspension and colloid, are already under heterogeneous. So when we say heterogeneous mixtures, there are 2 or 3 states of matter or phases in the mixtures. Suspension, for example, when you mix oil and water, you notice that one settle on top of the other because they are insoluble. Oil is insoluble with the universal solvent water. So no matter how much effort you try in mixing them, they will form layers. So the formation of layers indicates that the mixture is a suspension. Colloid is characterized with one phase that is distributed with another phase. For example, you mix starch and water. After mixing the two, you will observe a cloudy mixture. The cloudy mixture is a result of solid starch particles being distributed or scattered in the liquid. So that's how you can distinguish between or among solution, suspension, and colloid. Let's try the following. Let's classify the following substances. Sugar is an element or a compound. Yes, it is a compound because sugar contains 3 elements: carbon, hydrogen, and oxygen. This one is a silver medal. So what kind of substance is this? So when we say classify the substances, we only have 2 options the element and the compound. So that's only how we will categorize the following. So again, sugar contains 3 elements, carbon, hydrogen, and oxygen, and therefore a compound. Silver metal contains 1 elements, silver, so this is only an element. And the third one, alcohol, also contains carbon, hydrogen, and oxygen, and therefore another compound. Let's classify the following samples of matter. So this time as pure substance or mixture. Vinegar, having combined ingredients in addition to acetic acid, is classified as mixture. Another is salt. Salt is NaCl earlier. So NaCl means, suppose it has iodine in it, then we can still categorize it as, we can also categorize it as homogeneous mixture. But assuming that it is just NaCl, so the correct classification is compound, pure substance or compound. And this one, soy sauce, is the same as vinegar. It is also a mixture of several components or ingredients, and therefore a mixture. Now let's classify the following mixtures that can be formed by combining the following. Salt, as you know, is soluble in vinegar, as you have observed several times. So they will form what kind of mixture? Homogeneous mixture or solution. Starch and water, I have mentioned earlier, will form a heterogeneous mixture, specifically a colloid. And 3, alcohol and water. Alcohol and water can mix in different proportions, and therefore a homogeneous mixture. Let's now move on to representing substances in terms of chemical formula. Chemical formula expresses the composition of molecules and ionic compounds in terms of chemical symbols. Some chemical symbols are hydrogen, it's HO for oxygen, C for carbon, Fe for iron. For the rest of the symbols of elements, you can check the modern periodic table. You can see there the existing elements on Earth. Some examples of chemical formula are H2O for water, CO2 for carbon dioxide, NaCl for salt, FeSO4 for ferrous sulfate. So this is an example of a modern periodic table. You can purchase it in any store, from any store. It costs a small amount of money. So this is a requirement when you are taking a general chemistry class. So you can see here the many other ways of classifying elements. So apart from classifying elements as metal, non-metals, and metallites, it can also be they can also be classified in many different ways as indicated in the modern periodic table. So give the chemical formulas for the following substances or symbols. Let's try this. So this is your electrical wiring. That is copper, and copper is Cu. Salt is NaCl, silver is Ag, vinegar is C sub 2, H sub 3, O sub 2, water is H2O, sugar is C6, H12O6, although this is only the chemical formula of the smallest unit of all carbohydrates. This is glucose. Alcohol is C sub 2, H sub 2, OH. Starch is C6H10O5. Iron sulfate or ferrous sulfate is FeSO sub 4. And gold, Au. Gold-like gems are substances that are commercially or readily available since production materials are accessible and affordable. In the case of gold, silver, platinum, and other precious metals, they are quite expensive or more expensive than those commercially or readily available. In the case of these two metals, gold and silver, the difference in cost or value is accounted for by the same factors: accessibility and availability. Gold is more expensive than silver though because it is rarer. So the amount of hard work and cost in mining affect the costing of materials made of metals. This is similar with commercialized gems. Diamonds are more expensive than other gems or minerals. Gems differ in quality and so differ in costs. Those with impurities will cost cheaper. Depending on the amount of impurities, the quality and cost of gems or metals that are used aesthetically are dependent on. So the greater the amount of impurity, the smaller the value. The purer, the higher the value. So that's how these mined metals and minerals are given cost, and the value. So in terms of impurities, there are common techniques in separating mixtures. But first, let us identify some techniques. First is, so all of us have done this. So when we are rinsing our rice before cooking, we do the process to get rid of the water. We do decantation. So decantation is simply pouring off the liquid portion and leaving the more dense materials at the bottom. Another is filtration. There are specific lab apparatus that are used. As you can see here, you have some apparatus like the glass rod, one container and another container. This container contains the mixture. The other container is to collect the liquid portion. We have here the funnel that supports the filter paper. The filter paper is the one that filters or separates the solid component from this mixture. When there are small particles of solid that are mixed with liquid, you can use filtration. So you can make use of spoon, fork, tongue to get the big components from the mixture. So you call the technique mechanical. Evaporation. Evaporation is the process employed by the people here, as you can see in the picture, to recover salt from seawater. So evaporation is simply allowing the liquid component from a solution to escape, evaporate, so that the solid that is dissolved originally in the liquid be left on the container. So that's how salt from the seawater is recovered, as you can see on this picture. Distillation is normally done when purifying water. Tap water is rich with impurities. So in order to get rid of the impurities, you can use distillation. Distillation employs two processes. We have the evaporation and condensation. So this is a simple distillation setup. So you can see here the container for the water to purify. You call that distilling flask. And then you have here another component to contain the purified substance. So what will be left here will be the impurities. So impurities purified. So we have here the thermometer to monitor the boiling point. Let's say you want to separate alcohol from water. Alcohol boils at 79 degrees Celsius, water at higher degrees Celsius. So you keep the temperature at around 79 degrees Celsius. So you will allow alcohol to evaporate completely and be recovered in this flask. This condenser is to speed up the condensation process. This is to cool down the steam coming from the distilling flask. But of course, to increase the condensation, there must be water to get in and out. It will only help the condensation process speed up. So that's how you purify solutions or separate solutions, components from solutions. Another is centrifugation. This is an example of a centrifuge. This is done when a mixture has components that have different densities. For example, blood. When doing blood testing, the sample of blood is subject to centrifugation. That is to separate the components. So you will see after the process of centrifugation, the components will separate according to difference in densities. So for example, the red blood cells are separated, recovered at the bottom because red blood cells have the highest density among the other components in blood. So plasma is on top because it is believed to be of lowest density. Recrystallization or crystallization to many. This is the technique done in order to get rid of the impurities in crystals. So you will see here the crystals with impurities. So to remove the impurities, you will use a solvent, dissolve the crystals, allow the crystal to recrystallize, the solid to recrystallize. All the impurities will be left with the solvent. So you will recover only the pure crystals. The impurities will be left with the solvent. So that's how you can use the crystallization to separate the impurities or components from unwanted components from a mixture, a solid mixture. Let's say you are after only the gem of a greater value here, so you will need to have it powdered, dissolved in a solvent, recrystallize, allow the pure gem to or mineral to recrystallize and recover it. Same with metals. So metals are taken from mining sites, sometimes have impurities. They are being dissolved in particular solvents and then allowed to recrystallize, to be reformed and as pure metal substances. And that's it. Let's have this simple exercise. Can you suggest the best method to separate the components in the following mixtures? And for generalization, let's answer the following questions. 1. How do we differentiate between intrinsic and extrinsic properties? 2. How do we classify matter? Can we recall the chemical symbols or formula of common substances that we can see at our home? How do we compare some products on the basis of their components for use, safety, quality, and cost? And can we identify and describe simple techniques in separating components of mixtures? Go over your notes. I hope you have taken down notes and try hard to recall to answer these questions. Your correct answers will wrap up the lesson. Thank you for watching. Until next time.